Hello everyone and welcome back to my channel. Today we're going to be doing some more chain rule, but chain rule that's a little bit more complicated than before. So to kind of recap, we have chain rule, we have a function inside of another function. So when we take the derivative of f of g of x, we need to peel back that first layer and take the derivative of f, keep the inside exactly the same, and then multiply it by the derivative of the inside g of x. So f prime of g of x times g prime of x is chain rule. We can kind of take this and adjust it as we need to kind of get something else. So now that we've looked at some chain rule problems, let's look at ones that are a little bit more complicated. So when we look at this function right here, cosine to the fifth power of 3x squared. One of the first things that we can kind of do is rewrite it. So we have cosine of 3x squared raised to the fifth power. And looking at it this way, we can kind of see three different values. So our inside function is all of this stuff on the inside. It's that 3x squared. We have an outside function, which is going to be this to the fifth power. It also kind of includes these parentheses. And then we have our middle function this time, which is cosine. So when we do this, we kind of need to peel this back in layers. So we're going to deal with the outermost function, our middle function, and then the inside function. So we need to deal with the fifth power, then we need to deal with cosine, then we're going to deal with 3x squared. Okay, so our derivative, f prime of x, the derivative of a fifth power, we multiply the outside by 5. So 1 times 5 is 5. And then we take 1 away from our exponent. Everything that's on the inside is everything that's left over in the middle and inside function. So cosine of 3x squared is everything that goes in these parentheses. Okay, I've dealt with the outside. Now it's time to deal with the middle function. So we take the derivative of cosine. The derivative of cosine is negative sine. And we keep the inside function the same. So negative sine of 3x squared. And then finally, we're going to take the derivative of our inside function. So the derivative of 3x squared is 6x. I could rewrite this if I really wanted to. We have 5 times 6x times negative, so negative 30x. And then sine of 3x squared times cosine of 3x squared to the fourth power. So when we're dealing with this, it's just like peeling back more layers. Chain rule in a lot of ways is like an onion. Our next one, we have e to the power of the square root of sine of x. We have our inside function. If I were to plug in x, it's going to go inside of sine. We have our outermost function. I have to deal with e to a power last, and our middle function, which is going to be this square root. When we're dealing with square roots, we have to remember to change what our function looks like. So what we're really dealing with is e to the power of sine of x to the 1/2 power. So we have our outside function, which is e to a power. We have our middle function, which is going to be the 1/2 power. And we have our inside function, which is going to be sine of x. So the derivative of e to a power is e to that power. So e to the power of the square root of sine of x. Then we are going to multiply it by the derivative of our middle function, so the derivative of the 1/2 power, so 1/2 times our inside function sine. We take 1 away from 1/2 to get negative 1/2. And we take the derivative of sine of x, which happens to be cosine of x. If I were to rewrite it, things that I could do, we're going to have a division because we have a 1/2 for sure. But sine is also to the 1/2 power. So that means, or to the negative 1/2 power, which means it's going to move to the denominator. So we have 2 times 1/2 power means it's a square root, so the square root of sine of x. And then we have e to the square root of sine of x and cosine on the top. So just like always, everything just depends on what kind of problem we're given. These are all just free response problems because we're just trying them out. So we don't really have to simplify. If this was a multiple choice problem, we'd have to know what to simplify it to based off of the options it gives us. Okay, so we have h of x is equal to the natural log of tangent of 4x squared minus 12. So our inside function is everything on the inside. Our middle function is tangent, and our outside function is natural log. Okay, so the derivative of natural log is 1 divided by everything on the inside. In this case, our inside is tangent of 4x squared minus 12. We're going to multiply this by the derivative of now tangent. So the derivative of tangent is secant squared, and we keep everything on the inside the same. Then we're going to multiply it by the derivative of 4x squared minus 12. So 8x. And if I want to, I can just put everything in the top, just in the top. So I have secant squared of 4x squared minus 12 times 8x, all divided by tangent of 4x squared minus 12. There's a chance that we could simplify a little bit more, but it just kind of depends on what our problem is, what we need to do. So we might have been able to do something with our secant squared and tangent, but we don't need to right now. Okay. Secant of cosine of sine. So we have our outermost function, our middle function, and our inside function. So j prime of x is equal to, the derivative of secant is secant of x times tangent of x. So this is where we need to be a little bit careful. So secant of x is secant of whatever our inside function is, and tangent of whatever our inside function is. So secant of cosine of sine and tangent of cosine of sine. Okay, so we've now taken the derivative of secant. We're going to take the derivative of cosine. So the derivative of cosine is negative sine. So I have negative sine of sine. And then we take the derivative of sine, which is cosine. This is one of those ones that I would not probably simplify, and we just need to make sure we have enough parentheses because it's just a lot. But this is our derivative based off of chain rule. This last one here is when we have more than one thing that we have to deal with at a time. So when I'm looking at this problem, I have 4 times the quantity x cubed minus 5x squared all to the 10th power times sine of 5x to the 6th power. So I know that I need to use product rule. So we need to pick a u. So I'm just going to make that the first piece. And we need to pick a v. Okay, from here we need to take the derivatives. Well, looking at my problem, I have an inside and I have an outside function. I have an inside and I have an outside function. So I'm going to use chain rule for both pieces in my product rule, but overall I need to use product rule. So the derivative of 4 times the quantity x cubed minus 5x squared to the 10th power, we're going to use power rule first. So 10 times 4 is 40. We keep the inside the same, and we take 1 away from our exponent. Then we multiply by the derivative of the inside. So the derivative of x cubed, 3x squared, minus 10x. Same thing for this one. So we take the derivative of sine first. So we have cosine of 5x to the 6th times plus the derivative of 5x to the 6th, which is 30x to the 5th. So now what we're going to do is multiply these together. So I have k prime of x is equal to u prime. So all of this is u prime. We're going to multiply that by v, sine of 5x to the 6th, plus v prime times u. So the biggest thing here is just the amount that we have to write. If we were dealing with a problem like this, we would probably try to simplify it. In simplifying this, we want to look for things that they have in common. So between this piece and this piece, the big thing we have in common is that x cubed minus 5x squared to a power. I can even take out things like 10 from each thing because we have a 40 and a 30, and I can take out a 4. So there's a good chance I can actually take out 40 from both of these things. 4 times 30 is 120. So if I take out 40 from everything, I know that we are going to have 3 times 40. So if I were to simplify this, I would probably do 40, and then I have my x cubed minus 5x squared. The thing that they have in common is 9 of them, so I have to the 9th power times 3x squared minus 10x times sine of 5x to the 6th plus cosine 5x to the 6th times 3x to the 5th, and we have a x cubed minus 5x squared. This might not make it any better, but this could absolutely be something else, and we may even be able to simplify it more depending on what we need to do with it. So chain rule is one of those things we just kind of need to peel back all of these different layers in order to kind of get to the pieces that we need.